Okay, so let's get right into it. Almost everyone has played around with a chatbot like ChatGPT, right? You ask a question, you get an answer. Simple. But what I want to talk about today is a massive, fundamental shift that's happening behind the scenes. We're moving away from AI that just responds to us and into an era of AI that actively acts for us. This is way beyond the chatbot. Welcome to the age of the AI agent.
So what's the actual difference here? This slide breaks it down perfectly. On the left, you've got generative AI. That's what we're all used to. It's basically a one-shot deal. You give it a prompt, it gives you a response. That's it. Transaction over. But look at the right side. That's agentic AI. This is a totally different beast. It's a persistent system. You don't give it a prompt, you give it a goal. And from there, it creates a plan, takes actions, sees what happens, and then adapts. All on its own. It's a continuous loop, not a single command.
Let's put a formal definition on this. Agentic AI is all about autonomous, goal-driven systems that can run for long stretches with very little human hand-holding. And the magic ingredients are planning, memory, and the ability to use tools. Here's an analogy I love. Generative AI is like a calculator. You punch in the numbers to get an answer. Agentic AI? That's like hiring an accountant to manage your entire financial life. One is a tool you use. The other is a partner you delegate to.
To really wrap our heads around this, we're going to cover 5 key areas today. First, we'll go deeper on what it really means to move beyond the chatbot. Then, we'll pop the hood and see how an agent actually thinks. After that, we'll look at some incredible real-world examples. And finally, we'll get into the tough stuff, the big challenges, like the coordination problem and the massive question of who's responsible when things go wrong.
Okay, first up, moving from passive tools to autonomous partners. Look, we are not just talking about a slightly better search engine. We're talking about a complete paradigm shift. We're leaving the world of simple Q&A and entering a future where we'll have digital interns, autonomous project managers, systems that don't just find information for you, but actually work to solve your complex problems, even while you're asleep. But how? How do they actually pull this off? You know, what's happening inside the machine that gives them this incredible autonomy? Let's take a look inside the core mechanic of how an agent thinks. This loop you're seeing is the secret sauce. It's what makes them autonomous. It all starts with perception, where the agent figures out the goal and what's going on around it. Next up is planning, breaking that huge goal down into small, manageable steps. Then comes execution, where it actually does stuff. You know, searching the web, running some code, using whatever tools it needs. And finally, and this is the really clever part, reflection. It looks at what happens, learns from it, and adjusts the plan. This cycle just keeps going and going until the job is done. No babysitting required.
And I want to be clear, this isn't some far-off science fiction. Agentic AI is already here, and it's making a huge impact. So let's pivot and look at some real-world examples of how this tech is being used right now.
I mean, just look at the range here. We're talking about agents optimizing incredibly complex factory workflows. In science, they're literally automating discovery, designing and running experiments on their own. They're personalizing financial advice at a scale humans never could. They're beefing up cybersecurity, detecting fraud, managing smart cities, creating custom learning plans for students. The list just goes on and on. The impact is touching pretty much every industry you can think of.
And all of this is being built on a whole new set of frameworks. This table shows a few of the big ones. You've got LangChain, which is kind of like the essential toolkit for connecting these AIs to the outside world. Then there's AutoGPT, which is all about creating one super autonomous agent that can handle really complex, long-term tasks. And then you have AutoAgent, which is really wild. It's designed to get multiple AI agents to work together as a team, collaborating to solve problems.
But, and this is a huge but, getting one agent to work is tough. Getting a whole team of them to cooperate effectively, well, that introduces a whole new universe of problems. Researchers have a name for this, the coordination problem.
When you get a bunch of agents trying to work together, things can go sideways fast. They can fail to communicate, their strategies can clash, but one of the scariest issues is something called herding behavior. This is where different agents, maybe because they're built on similar models, all make the exact same bad decision at the exact same time. Think about it. What happens if thousands of autonomous financial advisor agents all decide to sell the same stock in the same microsecond? That's the kind of systemic, catastrophic risk we're now facing.
Which, of course, brings us to what might be the single most important question in all of this. When one of these powerful, autonomous systems inevitably makes a mistake, who takes the blame? This is where we move beyond the technical stuff and into a massive ethical and legal minefield. Seriously, think about it.
If an autonomous agent running a power grid causes a massive blackout, or an AI financial advisor loses your entire life savings, who is at fault? Is it you, the user who gave it the goal? Is it the developer who built it? Or do we need to invent a whole new legal status for the AI itself? As you can probably guess, there are no easy answers here.
And this quote from a recent research paper just nails the problem. It says, "Even the developers cannot explain why the agentic AI made a certain choice." That's the whole black box issue. If the people who created it can't even understand its reasoning, how on earth are we supposed to assign responsibility when something goes wrong? It's a huge, unsolved problem.
And accountability is just one piece of the puzzle. There are so many other risks we have to figure out before we can deploy these things safely. They can be tricked by adversarial attacks, their data can be poisoned, they create huge privacy concerns, and, maybe most importantly, their very autonomy creates the risk of having no human oversight right when you need it the most.
So to wrap this all up, let's just reframe how we think about this. We are not just building fancier tools anymore. We are building autonomous partners. And because of that, the real challenge, the truly human challenge, isn't just about programming them to act. It's about deciding how much we can, and frankly, how much we should, trust them to act for us.